Doc Edgerton inspired us with awe and curiosity with this photo of a bullet piercing through an apple, an exposure just a millionth of a second. But now, 50 years later, we can go 1,000,000 times faster and see the world not at 1,000,000 or 1,000,000,000, but 1,000,000,000,000 frames per second. I present you a new type of photography, femtophotography, a new imaging technique so fast that you can create slow motion videos of light in motion. And with that, we can create cameras that can look around corners beyond line of sight or see inside our body without an X-ray, and really challenge what we mean by a camera. Now, if I take a laser pointer and turn it on and off in 1/1,000,000th of a second, which is several femtoseconds, I'll create a packet of photons barely a millimeter wide. And that packet of photons, that bullet, will travel at a speed of light, and again 1,000,000 times faster than an ordinary bullet. Now, if you take that bullet and take this packet of photons and fire into this bottle, how will those photons shatter into this bottle? How does light look in slow motion? Now, the whole event now remember, the whole event is effectively taking place in less than a nanosecond. That's how much time it takes for light to travel. But I'm slowing down in this video by a factor of 10 billion so you can see the light in motion. But Coca-Cola did not sponsor this research. Now, there's a lot going on in this movie, so let me break this down and show you what's going on. So the pulse enters the bottle, our bullet, with a packet of photons. They start traveling through, and they start scattering inside. Some of the light leaks, goes on the table, and you start seeing these ripples of waves. Many of the photons eventually reach the cap, and then they explode in various directions. As you can see, there is a bubble of air and it's bouncing around inside. Meanwhile, the ripples are traveling on the table. And because of the reflections at the top, you'll see at the back of the bottle, after several frames, the reflections are focused. Now, if you take an ordinary bullet and let it go the same distance and slow down the video again by a factor of 10 billion, do you know how long you'll have to sit here to watch that movie? A day, a week, actually a whole year. It'll be a very